As we mentioned at the end of the last video, when using the standard normal table here, there's actually 3 cases that can occur. Okay? And these cases are, the first one is when you want to find an area below a z-score. The second one is when you want to find an area above a z-score. The third one is when you want to find area between 2 z-scores. So we're going to look at each one of these cases and see what to do in each case. So the first one is areas below a z-score. Okay, so let's say I want to find an area here. We'll say I want to find an area below below a z-score of negative we'll say 1.92. Okay, so what you're going to do, so you want to find the area below a z-score of negative 1.92. So I'm going to put negative 1.92. It doesn't have to be perfect, but this would be like a little less than 2 standard deviations out. And it's going to be on the negative side of 0 because it's a negative z-score. And then I want the area below. So when I say to below, I mean this area to the right of. Okay, it would have z-scores that are less than negative 1.92 further down. Okay, for this one, all you need to do is look up the z-score on the table. So like negative 1.92, and I get 0.0274. So this is 0.0274. So that would be the area, and that corresponds to 2.74%. So what it would mean is that for any normal population, 2.74% of the observations has z-scores that are less than negative 1.92. Okay? So let me try one more here. We'll say, not the second case, sorry. Another example. So we'll say an area below z equals 0.08. Okay, now that is a z-score that is very close to the center, isn't it? So this is 0, and this is 0.08. So this is like really close. Okay? That's really close. And so when I look that up, I'm going to get this area below. Okay? And so let's see. The way I would look this up, notice the thing I look up down here would be 0.0. So I'm going to go on the positive side, and 0.0 is actually at the top of the page. And then I would go over to 0.8 here, and then I would get 0.5319. So this would be 0.5319, which would be 53.19%. So, and that makes sense because that's a little over a half of the area, right? 0 would be half of the area, below 0. So below this is a little more than half of the area. Okay? So if I were to write a rule for case 1, basically, the rule would be look up z-score on table. The area on table is the desired area that you're looking for. So in other words, this is the simplest case. because the table is set up to give you, always give you the areas below the z-score, when you look it up, this number on the table is actually the percentage that you want. And that's the simplest of the three cases. Okay, so now what are you going to do if it's above? You want the area above a z-score. Okay, so this is the second case. And it's the area above a z-score. So let's say I want the area above z equals 2.07, we'll say. Okay, well, draw out your curve, 0 in the center. 2.07 is a little more than 2 standard deviations above the mean, so this doesn't have to be perfect, but something like that, and it's above the mean. And then I want the area above that, so I'm going to shade this side now. These are the values that are above, okay, this half. So now when I look this up, it's going to give me this area, and that's not the area I want. That's the area below. But we need to find that first, so let's find that. So on the positive side, 2.0.07, so where these cross, I get 0.9808. So this is like 0.9808. Okay? So now the way that you get the area above is you subtract from 1. Because the total area is like 1, and so the area below plus the area above is equal to 1, and so to get the area above, you would take 1 minus the area below. Okay, so 1 minus that is going to give me 0.0192. Let me make sure I got the right answer. 1 minus 0.9808. Yeah. Okay. So this is actually this is the same idea as when you do a the complement rule in doing probability. You're given, these two are like complementary events. If you know one, you can find the other by subtracting from one. It's very, very similar to that. Okay. And so we get 1.92%. Okay, so that's the percent that lie above, not very much. So now if I converted this into its percent here, then you could see that these two actually add up together to be 100%, just like these two numbers add up to be 1. Okay, so if I had to write a rule for this one, my rule would be look up z-score on table and subtract area on table from 1 to get the desired area. So whenever you want to find the area above, you look it up on the table, but you have to subtract from 1 to get the area above. So let's try another one. Let's say z equals a negative 0.63. Okay. So this is 0, negative 6.3. That would be below the mean, and it's not even 1 standard deviation below, so it's a little close to 0, like that. And I want to get the area above, so I want to get all this area. So when I look up negative 0.63, I'm going to get the area that lies below it. So now I go to the negative side, 0.6 0.03, and these intersect at 0.2643. 0.2643. Okay, so that's not my final answer because I want the area above. So I got to take 1 minus 0.2643. So 1 minus 0.2643 is 0.7357. And that's the area above. That would be the same as 73.57%. That would be the percent of the population that lie above that particular z-score. Okay, so that's the area above. And what you're going to do is you're going to look it up and then subtract what you get on the table from 1 to get the area above. The table will always give you the area below. To get above, you have to subtract from 1. So finally, the third case. And then in the next video, I'm going to give you a chance to do some of these. Okay? So, this is, you want to get the area between two z-scores. Okay, so we want the area, in this example, we'll say area between, let's say, 0 equals 0.75 and z equals 1.75. Okay, so here's what I do. I'm going to draw the curve. These are both positive. One is a little closer to the center because it's not even 1 standard deviation out. The other one's almost 2, so it's a little further out. So those are my 2 z-scores above the mean, positive, above the mean. So now I want the area between these 2 z-scores. And so it would look like that. Okay, now here's the idea. If I were to look up this one, I would get all the area from this one on down, and that's going to be too much area. So what I have to do is I have to subtract the area below the other one in order to get the area between. So I'm going to be looking both of these up. So one positive 1.75, and I get 0.9599, so 0.9599. So that gives me all the area below 1.75. And now look up 0.75, and I get 0.7734. 0.7734, and that's all the area below 0.75. So to get the area between, I subtract the 2 areas. I take the larger one minus the smaller one, and that's going to give me the area between. So 0.9599 minus 0.7734. So I get 0.1865, and that's the area between them. So 18.65% of the area lies between these 2 z-scores. Okay, so if I were to write a rule here, I would say look up both z-scores on table. Desired area is larger area minus smaller area. And that's how you find the area between. Okay, so let me do one more example. And for this one, what I'm going to do is let me do this example here, where we have negative 1.75 .00 and positive 1.00. So I want the area between these two. This is -1 and +1 for my z-scores. Okay, so on the positive side, I look up 1.00 and I get 0.8413. So this area is 0.8413. And then the area for a -1.0 is right here. And I get 0.1587. 0.1587. So I'm going to take 0.8413 minus 0.1587. And that's going to give me the area between these two. So 0.8413 minus 0.1587, and I get 0.6826 here, and that would be 68.26%. Okay, and this makes sense because in the beginning, when we did the normal distribution, right, within one standard deviation on either side of the mean was 68% of the data, right? Well, this is the actual percentage. 68.26% of the data lies within one standard deviation, and they're rounding it to the nearest percent, okay, to get 68%. So, okay, so when you want to find the area below the z-score, you just look it up on the table. When you want to find the area above the z-score, you got to look it up on the table and subtract the area from 1. When you want to find the area between two z-scores, you have to look both of them up and subtract the two areas. So on the next video, I'm going to give you a couple of these to try.